Lambda is a function offering by AWS. Azure has functions, AWS has lambdas, and they're basically idempotent code pieces that execute in an ephemeral context, and they execute usually based on events. You can use it as like a web server, you can use it as an event-based system, you can use it with state machines. If you can invoke a Lambda from some context, and AWS has different contexts, whether it be on a schedule, by action, or by request of user, it can be invoked, it can do things, and it can be pretty nifty. Now, the thing is with Lambda is that you actually have to be pretty careful with the way that you provision it. You have to be pretty careful with the way that you write the code. And you have to be cognizant of different things that can lead to poor outcomes. Now, Lambda, and by no means should it necessarily be used as a server state. It's not a server. There's no such thing as a server state with Lambda. If you were to create a website using a Lambda, you can do that. I personally have done it with S3 and Lambda, as well as CloudFront, but it's mostly S3 being the data piece and kind of being the data store on the back end. And then everything else is basically just Lambda for state management, nothing to do with really web requests. Now, one thing that I ran into recently is trying to make my Lambda go from a ridiculous 20-second execution time to now the average execution time being about 5 seconds. Now, the way that I did this was really two things. One is writing the code better, and two was using Java 11 cold start. So I decided to use Java. If you don't know, Java is really bad with AWS Lambdas when it comes to cold start. Cold start is the period where the Lambda basically has not been invoked, it has been interacted with, it needs to start, it needs to warm up, and it needs to initialize before it can execute and make changes. Now, the thing is, if you write a Lambda in a wrong way, or if you have a Lambda with a lot of boilerplate, it can be a very long startup time. If, for example, you have a Lambda with Spring Boot, you can potentially see times of 20 to 25 second cold start time. Now, that's actually potentially an okay status depending on how much memory you allocate, because the more memory, the faster the cold start usually is. For me personally, I use 1 gigabyte when it comes to the memory, and then when it comes to temp storage, it's like 512. I don't really use a lot of temp storage. Now, when it comes to my mistake, my big, huge, gigantic mistake, is that I was actually doing something that you would think is not that big of a deal, but it actually was a gigantic deal. And that was that I was provisioning my Lambda, and what I was doing is that I wasn't properly using the init state. Now, what I mean by the init state is that when you write a Lambda, there is your handler method. There is your handle request method. This is the method that when your Lambda gets invoked, all of the code within it wakes up. It now has to initialize. It now has to run. It now has to go. It is a zombie coming back to life from the dead. But your init can actually do a lot more than your handle requests. As a matter of fact, it can do so much more that AWS has now started charging people money for your init state, because people are getting around the Lambda cost by doing a bunch of processes in the init state and not in the handle request state, which basically is kind of sort of gaming the system. It's a good design strategy, but from AWS perspective, if 90% of compute is an init and they're not charging you, you're basically getting ripped off. So what's happening here that I changed, the big change, is that I had two things that I did that made a huge difference. Number one, I created an S3 client that was static that could be used and passed down to this handle request. Number two, I created a Firebase application, which is similar to a client that was static and can be passed down in this request. Why is that significant? The reason why that's significant is that it will exist in the Lambda's init state. Because it exists in the Lambda's init state, you get a lot of benefits. So immediately, after I made this change, without doing cold start with Java 11, I was on Java 8, I made this simple change. I already was using pretty much the same structure. The only difference is now I passed down the client 10 seconds right off the bat. So it went from a ridiculous runtime of 20 seconds to 10 seconds. So you can kind of see that here, where I made that change and it was noticeable, and it was basically 10 seconds. Now, the next thing I did was I actually tested this out with pre-provision concurrency. If you don't know what pre-provision concurrency is, it's basically the Lambda has, it's kind of like sacrilegious, but it can work where you basically have certain count of instances for your Lambda that are in an always awake state. Before this, what I was doing, I was actually doing a really bootlegged warm-up step of I would have a scheduled event ping the Lambda to keep it warm. But what would end up happening is that even though I was doing that, eventually the Lambda would have a refresh period, because Lambdas, the way it works with a Lambda is that you are essentially having this init state be a little bit less ephemeral. But no matter what, there are periods of time where the container needs to get refreshed or some type of hardware needs to be moved, and you're not guaranteed to have, you know, your pre-provision item to be there. And that's what was happening here, where about every hour or so it would refresh. I would get the 20-second timer, and it basically kind of slowed down my process. It didn't necessarily, the way I'm using this Lambda is the background process for data enrichment, so it's not the end of the world that it was 20 seconds, but it's still not what I wanted, and it kind of was the end of the world because the SLA here is sub 10 seconds. It's not something like a web request where it needs to be sub 1 second or 500 milliseconds, but it is something I want it to be within 10 seconds. So that was a huge issue. And what ended up happening is that I did test it with concurrent provisioning. It was a lot better. It was about 5 seconds again, but what I realized is, okay, you know, that's concurrent provisioning. It costs money. That's not free. And one thing that Lambda and AWS does is that they actually give you something called cold start for free. So in order to do AWS Lambda cold start, or snap start, pardon, you need to be having a Java 11. It must be Java 11, which wasn't a big deal to me because whenever I was writing my code, it was basically in Java 8. So whatever I did fit to Java 11. And then once you have it set for Java 11, what you can do is you can go into configuration. I do believe SnapStart works with versioning, if I'm not mistaken. I think you do need to use versions. And what you do is you basically say, okay, here's my setup. I'm using 1024 memory, 512 ephemeral, and then SnapStart. Now, what SnapStart does, again, you have to use Java 11 minimum. And what SnapStart does, it says reduce startup time by having Lambda cache a snapshot of your function after the function has initialized. To evaluate whether your function code is resilient to snapshot operations, review this information, Now, what SnapStart is going to do is it's actually going to save a lot of time when it comes to network connections. So, believe it or not, just the network connections to S3 alone was taking about 5 seconds on cold start, absolute cold start. And the same thing was true with Firebase. So what ended up happening is that if you were to do this Lambda without SnapStart, without anything, you just have a hello world, it was about maybe 5 seconds to run, right? You add the S3. S3 by itself was 10 seconds. The processing and the business logic is about a second. So you end up having a scenario where it takes 10 seconds for the Lambda to wake up. It then takes another 10 seconds for it to connect, and then it takes about a second to actually execute. So the huge change that I made was putting all of the client initialization before the handle request, passing it into the handle request method. And then the second thing that I did that helped tremendously, it made the average time go from 10 seconds. So what made it go from 20 seconds to 10 seconds is putting the client initialization before the handle request method. What made it go from 10 seconds to 5 seconds was initially the provisioned concurrency, but I changed it to use SnapStart just to see what the difference would be, and it ended up being about 5 seconds. So right now, if I were to ping this Lambda in a cold state, it responds, well, it wasn't in a cold state, it responded in less than a second. But on average, it responds within 5 seconds. Now, once the Lambda's warm, that's when you basically don't have much of an issue. It's basically, you know, 500 milliseconds, sub 500 milliseconds. So for me, this is fine. 5 seconds is pretty good. If I wanted to tweak this some more, maybe I would give it a little bit more memory. Maybe I would look into caching things, if anything, if I needed to, using S3 as a cache. If I needed to, I don't think I need to. 5 seconds is acceptable, 5 seconds is good, and 5 seconds is a hell of a lot better than 20 seconds. Now, with that being said, I at least know enough that I can't expect too much from Java Lambdas. So if I do anything with a website, so for example, one very small example, but it is a legitimate example, is that I wanted to have my website go from, like if I go to about, I wanted it to default to about/index.html. And that actually does work, and it ends up being pretty good when using a AWS Lambda function. And I use this, it's basically a redirect. Ironically, using a Lambda was much easier than doing all the network stuff with Squarespace or anything with AWS. And it's pretty simple. All it is that if your request is coming in and if the last thing is a slash, go ahead and default it to index.html. So that's what I did here. It pretty much, it simplifies it for me. I just didn't want to type out index.html. I feel like it looks a lot cleaner when you load the website and the about section just says /about. It looks cleaner to me. So I did that with this Lambda, but this Lambda is using Node. Now, Node is pretty good. From that 2021 study that Medium.com ran, it was about 700 milliseconds to about 500 milliseconds average. Node is probably even better now. I mean, if I were to go ahead and look at the monitor for this, I don't use it that much. Like, I don't interact with the website that much. But if I were to try to see the average milliseconds, it looks like it's just about, I mean, it's basically sub 100 milliseconds, which is pretty good. Granted, understand it's extremely simple. It's not really doing anything. It's also using, this is integrated with CloudFront distribution. The way this works is that CloudFront basically looks at this Lambda to fill in gaps for the routing. So when it goes to /about, it'll ping this Lambda, and this Lambda will say, okay, go get index.html. Like that's the thing we're looking for. And it's 100 milliseconds. That's a far cry away even from the Java Lambda, which in a pretty good state does 500 milliseconds. But then again, I'm using Java for a reason. I'm doing a lot of back-end logic. I'm doing a lot of different things where I think that 5-second trade-off makes sense. Because if I were to use Node for that, it would be a lot less unit test coverage, just because I have more experience with Java and that's the way I have it set up. I also use test containers with Java and Maven, so I feel like that's also a bonus. So the way I have it set up, the way I have it packaged, the way I have it pushed, I think it makes sense where it's 5 seconds, where it's about 4.5 seconds, 4-second cold start, and then about 500 milliseconds of processing time, which again is acceptable. And also, one thing that is amazing about this and why you should genuinely consider doing cold start over pre-provisioned concurrency, as well as over doing any type of like hack way of what I was doing, which was pinging the Lambda, is that if you do get an influx of requests and you basically now have your Lambda scale horizontally, you're going to have that P99 be 5 seconds. Worst case scenario, 5 seconds, which is pretty good compared to 20 seconds. So having that P99 be 5 seconds is actually amazing because that's the worst case scenario. That's the slowest this Lambda will ever be. And not only is it the slowest this Lambda will ever be, but within a relative time span, within like 5-10 minutes, if the Lambda has been interacted with, the next request is going to be 500 milliseconds. So in that scenario, you would more than likely have one 5-second request. At that point, it would then, when pinged again, would be 500 milliseconds. And only if the load exceeded the barrier that AWS had deemed appropriate, would it then horizontally scale, add another Lambda for executions, and then that would have a cold start occur, which, because we're using Java 11 with snap start, is 5 seconds at worst. So as you can see, doing it this way makes a lot of sense from a design perspective. You will now have the horizontal scaling built in, and also from a cost effective. The way I was doing it before is that I was having a scheduled event. I can show it's disabled right now. I'm not using it because it kind of isn't necessary. Kind of after this change, it's not needed. But what I was using was Amazon EventBridge Scheduler. And what I would do is basically invoke the Lambda, basically keep it warm. By the Lambda being warm, it would not be slow. And that's okay. It's not necessarily the best way to do things. It honestly really is something that lends itself more to ECS if you're really going to be doing it in that way. But basically all it is that AWS API Gateway Lambda ping basically would ping the Lambda. I had it set for like, at the moment I have it as an hour, but before I had it every minute, which was okay. But again, there is like kind of a manual refresh or maintenance period for Lambda. From what I saw, every hour you're going to get a cold start, and that cold start is 20 seconds. And that doesn't meet the SLA requirements of sub 10 seconds. So it makes more sense to use cold start, and there's really no reason why you should not use cold start other than the fact that my code was not defined properly to lend itself well to Lambda and lend itself well to cold start. So I think if you do end up using a Java Lambda, which you need to kind of treat with care and kind of, use kid gloves, because it is historically and in fact one of the slower options when it comes to Lambda. You want to write it in a way where the client code is done before the handle request. You want to write it in a way where the client is reusable between the states, and allow cold start to basically be optimized and use that in order to avoid situations where you're reinitializing your client, reinitializing network connections, reinitializing these different pieces. Now, from my personal perspective and my personal experience, I have been using US East for majority of the changes. I've been using US East for majority of the deployments. With that being said, from my understanding, there are certain regions that do not allow cold start, at least up until last year. Paris, for example, does not allow cold start, at least up until last year. I haven't done the research into this, specifically outside of US East. So take that into consideration, that perhaps if you have a Lambda that you want to have cold start, you don't want it to be too slow, you might want to consider just using Node.js, Python, or Golang, because you're basically not guaranteed to have this in every region. You can do the research beforehand. But for my case, it makes perfect sense. It's perfectly fine. Worst case scenario, if cold start did not exist, I would have used pre-provisioned concurrency. In that case, it would have cost me an extra $5 a month per Lambda. So it is a little bit better to use cold start for cost as well as just effect. I can see that pre-provisioned concurrency and Lambdas with cold start or snap start have similar performance. So having snap start where it's free, where it's used, is much better. And it's also worth mentioning that if you have a Lambda be in a snap start configuration, you cannot also have it in a pre-provisioned configuration, because they kind of clash with each other. They kind of accomplish the same goal differently. But yeah, I think that's very fair to say that for Java Lambdas, snap start is a must. And what's even more important is making sure that you write your code in such a way that a lot of the logic, a lot of the work is done before the handle request method, in order to get that network connections out of the way, any type of database connections out of the way, and avoid any issues that is going to happen deeper inside your Lambda. And that will save you a lot of time, a lot of effort. And this is something, just for context, I was aware of, but I did not understand the literal designation between before the method and after the method. I was under the incorrect assumption that if I make static client code, if I make a static S3 client and have it defined later in the handle request, that AWS is smart enough to know that it's static and keep it in the memory as if it is in it. That's not the case. It is literally anything that is before this method will get created and will stay in that init state and can be promoted and enhanced by cold start or snap start. And anything that is below here that happens in the handle request method, or any of the classes below that, is going to take a lot of time. So take that into consideration. Any type of redundant actions or things that involve client requests or client connections, whether it be database, S3, Firebase, whatever the case may be, you want to do that before the method. It'll save a lot of time, a lot of heartache. And again, for me, Java was an acceptable solution. If you're looking for sub 1 second, you're probably going to want to go with something like Node.js or Python, because that lends itself well and better to things that are not like Java, Kotlin, or C#, where for Kotlin and Java, the JVM is the big time consumption piece. And for C Sharp, that's the .NET environment that takes more time. So that's some things to take into consideration if you want to try to avoid this whole snap start debacle. You could go straight with Node.js. You can also edit in browser, which is also a nice little positive. But again, for me personally, Node.js is not as heavyweight as Java. I like Java. I want to use Java for this type of data enrichment, so that's why I did that. And that's pretty much my learning experience. I was able to literally make my Lambda run 4 or 5 times faster by simply changing the client initialization and then changing it from Java 8 to Java 11 and enabling Snap Start.